Picture a desk lit only by the glow of a screen. A keyboard is going off like rapid gunfire. Lines of code, or maybe a design, are stacking up on the screen faster than you can read them. There's electricity in the room. Fast, sharp, almost dangerous. Then it stops. The screen freezes on a blinking cursor. The camera pulls back and you see who's actually sitting there. Not a machine, not a genius, just an average person, completely burnt out, staring at nothing. Here's the question that's been quietly haunting productivity researchers for years. Why can one person produce 3 hours of brilliant work while another person grinds for 10 hours and barely finishes? It's not talent. It's not a rare gene. It's not some superhuman ability to just focus. Right now, without knowing it, you are paying a tax, an invisible one. It gets deducted from every single thought you have, all day long, and you've never even seen the bill. By the end of this video, you're going to see exactly what's been quietly draining your mental bandwidth, understand the actual biological machinery that controls your focus, and walk away with the precise blueprint elite performers use to make hard work feel almost effortless. Let's start with the tax you didn't know you were paying. Chapter 1. The Silent Cognitive Tax. Picture a clean desk, laptop open, one important document on the screen, a cup of coffee steaming beside it in slow motion. You're locked in, typing, moving. Then, to your right, your phone lights up. No sound. No ring. Just a soft glow and a little red badge for 2 seconds. You don't even pick it up. You just tilt your head, glance at it for maybe 10 seconds, and look back at your screen. No harm done, right? You didn't get sucked in. You're still working. Except your fingers slow down. You delete the sentence you just wrote. You read the same paragraph for the 3rd time, trying to remember where your thought was even going. This happens again in 10 minutes. And again after that. By the end of an 8-hour day, you've logged 8 hours in the chair. But if you're honest, you could count your actual output on one hand. You're exhausted, and you barely have anything to show for it. Most people believe multitasking is a skill you can sharpen with practice, that a 10-second glance costs nothing as long as you snap right back to work. It feels true. It's completely wrong. Here's the twist. Your brain doesn't have an instant off switch for attention. When you glance away, even for a second, a piece of your focus stays behind, tethered to whatever pulled it. It's not gone. It's dragging behind you. Think of an old arcade game, Snake, glowing neon on a retro screen. The snake is slithering, growing, weaving between walls, getting more complex by the second. Suddenly, a giant cartoon phone icon drops onto the board. You pause for half a second to read a text. You unpause. The snake slams straight into the wall. That half-second pause didn't just cost you half a second. It left a residue behind, a slime trail gumming up the path, throwing off every move that came after it. Psychologists call this attention residue. Switching tasks isn't a clean cut. It's messy. A piece of the old task clings to your mind and quietly sabotages your performance on the new one. The more often you check, the thicker that residue gets, until you're operating in a permanent, self-inflicted fog. A business professor named Sophie Leroy proved this in the lab. She had people switch from solving word puzzles to reviewing job resumes, and the ones carrying attention residue performed noticeably worse on the second task, every single time. Cal Newport calls what most of us do pseudo-focus. We tell ourselves we're deep working, but really we're punctuating real work with constant little glances, rarely going more than 10 minutes without a quick check. It feels like diligence. It's actually self-sabotage on a loop. So here's the shift. Put a hard physical wall between you and your devices during focus blocks. Not a promise to yourself, an actual wall, another room, a locked drawer, airplane mode. The very first time you try 90 uninterrupted minutes like this, you'll notice something strange. You'll finish in 2 hours what used to eat an entire distracted afternoon. It won't feel like willpower. It'll feel like your brain finally exhaling. But here's the part that trips people up next. Even when the room is completely silent, even when the phone is locked in another room, your own brain can still throw up a wall of resistance. Why does that happen? To answer that, we need to go straight into the chemistry of motivation itself. Quick pause. If this is clicking for you, hit subscribe now, because what's coming in the next chapter is the part most people get completely backwards about motivation. You'll want to see this before you try to force yourself through your next hard task. Chapter 2. The Motivation Illusion. You're staring at a blank document. The internet's blocked. Your phone is in the other room, exactly like it should be. There's nothing left to distract you, and yet you're frozen. You open a new tab to look up some detail you don't actually need yet, or you start reorganizing your desktop folders, or somehow you're suddenly very interested in the weather forecast. There's a real physical heaviness to this moment. The task in front of you feels boring, oversized, almost painful to touch. And the story you tell yourself is familiar. I'm just not in the zone today. I don't have the motivation. I'll do this tomorrow when I feel more inspired. That search for inspiration is exactly what turns into chronic procrastination. The big, important projects get shoved to the last possible minute. The work that finally gets done is rushed and mediocre, and somewhere underneath it all, a quiet belief starts to grow. Maybe I just don't have what it takes. Most people think dopamine is a pleasure chemical, something that gets released after you win, after you finish, after the fun part, and they think they need to feel motivated before they can start something hard. Here's the twist that changes everything. Dopamine isn't a reward chemical, it's an anticipation chemical. It doesn't make a hard task physically easier. It changes the math your brain runs before you even begin. The equation your prefrontal cortex uses to weigh how much effort a task will cost against how much reward it's worth. Picture a scale sitting inside your brain, right in a region called the striatum. On one side sits a heavy, dark rock labeled effort. On the other side, a small pile of gold coins labeled reward. When dopamine is low, that rock looks enormous. The scale barely budges. Now watch what happens when dopamine gets injected into the system. The scale suddenly tips. Not because the rock got lighter, because the coins started glowing, and suddenly they look worth carrying that rock for. That's the whole game. Your willingness to sit down and do hard work is the output of a constant cost-benefit calculation happening in your brain's striatum and caudate nucleus. When dopamine rises, your brain overvalues the payoff and undervalues the pain, and suddenly the same task that felt impossible an hour ago feels almost inviting. Researchers at Brown University, in a study co-led by Dr. Michael Frank and backed by the NIH, tested this directly. 50 participants chose between easy and difficult mental tasks for money, and the ones with naturally higher dopamine consistently picked the harder tasks, not because they were more capable, but because their brains were focused on the reward, not the cost. When the researchers boosted dopamine artificially with medication, the same shift happened again. Motivation went up. Actual ability never changed. So the shift here is simple. Stop waiting to feel motivated and start manufacturing the spike yourself before the work begins. A 1 to 5 minute cold shower. 40 Hz binaural beats, something short and physiological that primes the system before you ever open the laptop. Do this once, and you'll notice the friction of starting almost disappears. You're not dragging yourself into the work anymore. Something is pulling you toward it. But let's say you've done all of that. You've killed the distractions, primed your chemistry, and you're finally moving. Then, out of nowhere, your brain floods with unrelated thoughts, an unanswered text, an unpaid bill, a project you left half-finished 3 weeks ago. Why does your own mind keep sabotaging the very focus it just built? That answer is waiting in the next chapter. Chapter 3. The Ghost Loops of Working Memory. You're finally in a groove. Distractions gone, dopamine primed, fingers moving fast. And then, completely uninvited, a thought drops in, I never replied to that email from my landlord. Or, I still need to buy groceries tonight. You try to wave it off, but it doesn't leave. It just sits there, like a pop-up ad that refuses to close, quietly pulling at the edge of your attention. A low hum of anxiety starts underneath everything else you're doing. Multiply that by every half-finished task, every unanswered message, every open project sitting in the back of your mind, and by the end of the week, your working memory is completely maxed out. You're mentally exhausted, sleeping worse, and somehow still swamped, even though you never stopped working. Most people assume they can just hold all of this in their head, that a to-do list is nothing more than a scheduling tool, helpful for logistics, but with zero effect on how their brain actually performs. Here's the twist. An unfinished task doesn't sit quietly waiting for you. It becomes an active tension system running in the background of your mind. The instant you leave something incomplete, your subconscious keeps chewing on it, burning working memory, and firing off those little intrusive thoughts, whether you asked for them or not. Imagine a busy restaurant in 1920s Berlin. A waiter is weaving between tables, carrying a tray loaded with food, somehow keeping track of 5 different unpaid orders in his head, each one glowing in bright neon green inside his mind. The moment a table finally pays their bill, a hand sweeps a wet cloth across that mental chalkboard, and the glowing order disappears into flat, dull gray. That's exactly what's happening in your head right now. Every unfinished task is still glowing neon. Every completed one has gone quiet. This is called the Zeigarnik effect, your brain's tendency to remember unfinished tasks far more vividly than finished ones. An open goal creates a kind of psychological itch, a quasi-need that stays active and keeps demanding a slice of your attention until it's resolved. It was first discovered in 1927 by a Soviet psychologist named Bluma Zeigarnik, after she noticed waiters could perfectly recall complex, unpaid orders but instantly forgot them the moment the bill was settled. She built lab experiments around it, puzzles, bead threading tasks, some interrupted, some completed, and found people remembered the interrupted ones almost twice as often. Here's the part that actually matters, though. A study by Masacampo and Baumeister in 2011 found something surprising. You don't actually need to finish the task to quiet the noise. You just need to make a specific, scheduled plan for when you'll do it. That alone is enough to shut the loop down. So every evening, do a full brain dump. Write down everything unfinished, and for each one, decide exactly when and how you'll handle it. Once that plan exists on paper, your brain treats the task as handled. The tension releases, the background noise drops out, you fall asleep faster, and the next time you sit down to focus, there's nothing quietly fighting you for space. Now you've cleared the noise, the environment, and the chemistry. But how do all 3 of these pieces actually combine into that rare state where time disappears, effort stops feeling like effort, and your output looks almost inhuman? That's what we're going to unlock next. Chapter 4. The Flow Blueprint. You're back at that same desk, but everything about it has changed. There's a Do Not Disturb sign on the door. The phone isn't just silenced, it's locked away in another room entirely. You sit down, and for a second, you feel that familiar pull toward distraction. But instead of wrestling with it, you run through a short, repeatable ritual. The same one every time. Within minutes, the resistance is just gone. That nagging inner voice that usually critiques every sentence goes quiet. You stop noticing yourself typing. You stop noticing time. You become the document. Hours pass. The work coming out is sharp, clean, some of your best. You glance at the clock expecting 15 minutes to have gone by. 90 minutes are gone. You've crossed over from struggling through your day to operating at what feels like peak biological capacity. Most people think flow, being in the zone, is a rare, almost mystical event reserved for elite athletes or artists. Something you get lucky into, not something you can build on command. Here's the twist. Flow isn't mystical at all. It has a precise, measurable signature in the brain, and it's entirely trainable. You can engineer it by deliberately triggering the conditions that quiet down your brain's distraction-prone default networks. Picture a 3D brain scan lit up during a moment of anxiety and scattered focus. The default mode network, the part responsible for rumination and self-criticism, is glowing hot red and yellow, chaotic, restless. Now watch what happens as flow sets in. A cool blue wave rolls across the prefrontal cortex. The red noise goes dark. What's left is a clean, synchronized rhythm of blue and green, organized, efficient, calm. This is called transient hypofrontality, a temporary quieting of the prefrontal regions responsible for self-monitoring and rule-following. That's the exact mechanism that silences your inner critic, warps your sense of time, and makes difficult work suddenly feel weightless. Psychologist Mihaly Csikszentmihalyi first documented flow back in 1975. Since then, a meta-analysis spanning 28 separate studies identified 3 conditions that consistently show up right before flow begins. A balance between challenge and skill, a clear goal, and immediate feedback on how you're doing. Brain imaging research led by Ulrich and colleagues in 2014 backed this up directly, showing that flow states physically deactivate the medial prefrontal cortex and the amygdala, the regions tied to fear and self-judgment, while synchronizing the brain's executive and reward circuits. Stephen Kotler's research adds another layer. Flow floods your system with a cocktail of dopamine, norepinephrine, and anandamide, locking your attention fully into the present moment. So before your next deep work session, run this 3-step protocol. First, write down one crystal clear micro goal, exactly what done looks like for this 90-minute block. Second, calibrate the challenge to sit right at the edge of your ability. Too easy, add a constraint. Too hard, break it into smaller pieces. Third, build in immediate feedback, something visible, like a live word count or a running test result, so you always know exactly where you stand. Do this consistently, and you stop waiting for flow to visit you by accident. You start walking straight into it, on schedule, almost every time. But there's a warning here. Flow is powerful and expensive to run. Push your brain at peak output without respecting its recovery limits, and this illegal level of productivity will eventually collapse into a crash. So how do you actually make this sustainable, for good? Conclusion. We're back where we started. Same desk, but this time, warm morning light spills across the room instead of the cold glow of a screen at midnight. You sit down, not by forcing yourself, but by stepping into an environment you built on purpose. A single sticky note with one micro goal. Your focus ritual already running in the background. No frantic typing, no panic, no nervous glance at a silent phone. Just calm, steady, unstoppable motion. Here's the deepest lesson in all of this. High output performance was never about gritting your teeth and forcing yourself through sheer discipline. Willpower is finite. It runs out every single day. Real productivity is an architecture problem. You're not trying to work harder. You're trying to design an environment and a chemistry that make hard work feel natural. So let this be the moment you drop the old story. Not, I'm lazy, I don't have the willpower to focus, but I am the architect of my own cognitive environment. When I set the right biological triggers, focus and motivation happen automatically. Once you stop fighting your biology and start engineering it, you don't just work faster. You unlock a level of performance so effortless, it feels illegal.